Imagine this. You're sitting on a train and it takes off, not into the air but off the tracks. You're floating on a cushion of magnets, zipping along at hundreds of miles per hour. This isn't science fiction, my friends, this is Maglev. Maglev trains use the power of magnets to levitate or float above the track. This means no friction, which means super high speeds and a super smooth ride. Buckle up, science fans, because we're taking a ride into the future of transportation. Maglev technology is already here with some systems up and running around the world, but the potential for this technology is enormous. Imagine a world where travel time between cities is slashed, where trains are whisper quiet and emissions free, where commuting becomes a breeze. This is the promise of Maglev, and it's closer than you might think. The idea of using magnets to levitate trains has been around for over a century. Early pioneers dreamed of frictionless transportation, and they knew magnets were the key. In the early 1900s, scientists started tinkering with magnetic levitation, building small-scale models and testing their theories. Fast forward to the 1960s and 70s, and things really started to pick up speed. Engineers in Japan and Germany, always at the forefront of technological innovation, poured resources into developing Maglev technology. They built test tracks, experimented with different designs, and pushed the boundaries of what was possible. And their hard work paid off, because in 1984, the world's first commercial Maglev system opened in Birmingham, England. Okay, so how do these things actually work? Let's break down the science behind Maglev. There are two main types of Maglev systems: electromagnetic suspension, EMS, and electrodynamic suspension, EDS. Don't worry, I'll explain it in a way that even your pet hamster can understand. EMS uses electromagnets on the train that are attracted to a steel rail on the guideway. These magnets lift the train just slightly off the track, and then other magnets on the sides propel it forward. EDS is a bit different. It uses superconducting magnets on the train that interact with magnetic fields created by coils on the guideway. This creates a repulsive force that levitates the train even higher above the track. Pretty cool, right? Section 4. Benefits of Maglev. Why we need this technology. So Maglev trains sound pretty neat, but why should we care? Well, for starters, they're incredibly fast. Because there's no friction from wheels on rails, Maglev trains can reach speeds of over 300 miles per hour. That's faster than most airplanes. This means shorter travel times, faster commutes, and more efficient transportation overall. But speed isn't the only advantage. Maglev trains are also incredibly smooth and quiet. Remember that lack of friction? That means no bumps, no vibrations, just a smooth, silent glide. And because they're powered by electricity, they're also incredibly energy efficient and produce zero emissions. Maglev is a win for speed, a win for the environment, and a win for anyone who values a comfortable ride. Section 5. Challenges facing Maglev. What's holding back this amazing tech? Now, before you get too excited, there are a few challenges facing Maglev technology. The biggest hurdle is the cost. Building a Maglev system is expensive. You need special tracks, powerful magnets, and a whole lot of infrastructure. This makes it a tough sell for governments and investors who are used to traditional rail systems. Another challenge is compatibility. Maglev trains can't run on existing rail lines. They need their own dedicated tracks, which means building a whole new transportation network. This can be tricky, especially in densely populated areas where space is limited. Section 6. The future is now. Maglev projects around the world. Despite these challenges, Maglev is gaining momentum. Japan is leading the charge with its Chuo Shinkansen line, a superconducting Maglev system that will connect Tokyo and Nagoya at speeds of over 300 miles per hour. China is also investing heavily in Maglev, with plans for several high-speed lines connecting major cities. And it's not just about high-speed rail. Maglev technology is also being explored for urban transportation, with smaller-scale systems being developed for cities around the world. So, while there are still hurdles to overcome, the future of Maglev is bright. This technology has the potential to revolutionize transportation as we know it, making it faster, more efficient, and more sustainable. So, keep your eyes peeled, science fans, because the Maglev revolution is just around the bend.